Somewhere out there, 146 light-years from the warmth of our sun, a world the size of Earth is quietly orbiting a star just like ours. Same size, same rocky surface, nearly the same year. Scientists have just spotted it, and for a moment, the whole astronomical community held its breath. But then came the number that changed everything. This planet receives less than 1/3 of the sunlight we do, HD 137010b. That's its name, and right now, it sits at the center of one of the most tantalizing and complicated debates in modern astronomy. Is it a frozen, airless wasteland, drifting silently through the dark? Or could it be something far more extraordinary? Stay with me, because this one goes deep. Let's talk about why scientists lost their minds over this discovery. Because the list of reasons is genuinely impressive. First, size. HD 137010b is Earth-sized. Not kind of Earth-sized. Not a bloated gas giant masquerading as a rocky world. We're talking a planet with roughly the same diameter as the one you're sitting on right now. Second, its year. This planet takes approximately 365 days to complete one full orbit around its star, Earth's year, almost to the day. That kind of orbital resonance is extraordinarily rare among the thousands of exoplanets we've cataloged. Third, and this is the part that makes astronomers sit up straight, its star. HD 137010 is a G-type star, a sun-like star, not a dim, flickering red dwarf, not a radiation-blasting giant. A calm, stable, middle-aged star, remarkably similar to our own sun. So you've got Earth-sized, Earth-year, sun-like star. That is essentially the planetary trifecta, the holy grail of exoplanet hunting. Now, how did we even find it? The answer is something called the transit method. Imagine shining a flashlight at a wall. Now imagine a tiny moth flying slowly across the beam. For just a moment, the light on the wall dims ever so slightly. That's exactly what HD 137010b did. It crossed in front of its star, and our telescopes caught that faint, fleeting dimming. That single crossing lasted 10 hours. 10 hours of precious data, pulling this frozen world out of the dark and into our awareness for the very first time. And now, the catch. Because there is always a catch. Remember that sunlight number? Less than 1/3 of what Earth receives. Let's make that real for a second. On Earth, a winter day in Siberia can hit -50 degrees Celsius. Scientists estimate that without any kind of atmospheric intervention, the surface temperature on HD 137010b could make Siberia feel like a beach vacation. We're potentially talking temperatures colder than Mars. A planet where the average temperature hovers around -60 degrees Celsius on a warm day. Mars at least gets almost as much sunlight as Earth by comparison. HD 137010b sits far enough from its star that liquid water, the universal ingredient for life as we understand it, may simply have no business existing on its surface. The oceans, if they were ever there, might be locked kilometers deep under permanent, continent-sized sheets of ice. A world that looks like Earth from a distance, but up close, utterly, brutally silent. Here's something important, something the headlines don't always say loudly enough. HD 137010b is not a confirmed planet. Yeah, not yet. Officially, it holds the designation of a planetary candidate, and that distinction matters enormously in science. Everything we know, everything, comes from a single transit event, 10 hours of dimming starlight. That's it. That is the entire body of direct evidence we currently have. Think about that. We're trying to understand a world 146 light-years away, based on one brief shadow. To officially confirm a planet's existence, unlike astronomers typically need to observe multiple transits. To see the dimming repeat at predictable intervals, confirming the object is truly in a stable orbit. With a 365-day orbital period, that means waiting at least another year, probably longer, just to collect the next data point. And gathering that data isn't easy. Ground-based telescopes face weather, atmospheric interference, and limited observation windows. Even space-based instruments have packed schedules and must balance competing scientific priorities. The tools that could crack this mystery wide open? The James Webb Space Telescope leads the list. Its infrared sensitivity could potentially detect the chemical fingerprints of an atmosphere, if one exists. ESA's Plato mission, designed precisely for finding and characterizing Earth-like planets around Sun-like stars, may well have HD 137010b on its target list, but for now, we wait. But science doesn't just shrug and walk away. It asks, what if we're missing something? Here's the theory that keeps astronomers up at night, in the best possible way. Atmosphere, a thick, dense, carbon dioxide-rich atmosphere, acts like a planetary blanket. It traps heat that would otherwise radiate back out into space. We see this in action right here in our own solar system. Venus, smothered in a dense atmosphere, maintains surface temperatures hot enough to melt lead, despite sitting further from the Sun than Mercury. Applied to HD 137010b, the math becomes genuinely exciting. Scientists estimate that roughly 40% of rocky planets in comparable orbits around Sun-like stars may retain substantial atmospheres capable of meaningful greenhouse warming. In that scenario, even receiving less than a third of Earth's sunlight, surface temperatures could theoretically climb into the range where liquid water becomes possible. Another 50% of modeled scenarios place the planet in a permanent deep freeze, all ice all the time. And around 10% fall somewhere in between, a geologically active world with subsurface liquid water hidden beneath frozen oceans, not unlike what scientists believe exists on Jupiter's moon Europa. 3 possible worlds, 1 planet, and we don't yet know which one we're looking at. HD 137010b isn't alone in raising these questions. The galaxy is full of strange, yet compelling worlds that stretch our understanding of what a planet can be. Let's take a quick tour. 22 light-years away, orbiting a red dwarf star, sits Gliese 667 cc. Its year lasts just 28 days. 28 days. By the time you've finished binge-watching a decent series, this planet has already completed a full orbit around its star. And here's the wild part. Despite being much closer to its star than Earth is to the Sun, it sits comfortably within the habitable zone. Red dwarf stars are significantly cooler and dimmer than our Sun, so the proximity essentially compensates. The catch: red dwarfs are temperamental. They throw out violent solar flares that could strip away a planet's atmosphere over geological timescales. Gliese 667 cc might be in the right zone, but the radiation environment would make our worst solar weather look like a mild afternoon drizzle. Then there's Kepler 22b, and it has been frustrating astronomers since the moment we found it. 600 light-years out, it sits almost perfectly within its star's habitable zone. It receives roughly the same energy from its star that Earth receives from the Sun. Surface temperatures, if the atmosphere cooperates, could theoretically average around 22 degrees Celsius, a pleasant spring day forever. But here's the problem. We have absolutely no idea what it's made of. Is it a rocky world with shallow oceans? A waterworld buried under a global sea, hundreds of kilometers deep? A mini gas giant with no solid surface at all? The data simply doesn't tell us. Kepler 22b is 2.4 times Earth's radius, large enough that multiple compositions are equally plausible. It is, in every sense, a beautiful open question floating in the dark. And then there's 55 Cancri e, just to remind us that not all rocky planets are remotely welcoming. 40 light-years away, this world orbits its star, at a distance of less than 2.5 million kilometers. Mercury, our solar system's innermost planet, orbits at roughly 58 million kilometers from the Sun. Let that sink in. 55 Cancri e completes a full orbit in under 18 hours. Its dayside faces temperatures that likely exceed 2,000 degrees Celsius, hot enough to vaporize rock. The surface is thought to be covered in a churning, rolling ocean of molten lava. It's a planet, it's rocky, and it is absolutely, comprehensively, and spectacularly uninhabitable. A useful reminder that Earth-sized and Earth-like are very, very different things. Finally, TOI 733b. A world that takes the concept of ocean to a genuinely staggering extreme. Located roughly 245 light-years away, this planet appears to be a water world. Not just a planet with oceans, but a planet potentially composed primarily of water. Scientists estimate that water could account for a significant fraction of its total mass, by existing as high-pressure ice deep within its interior and as liquid above. No continents, no mountain ranges breaking the surface, just water as far as the eye could ever see. A global ocean with no shoreline, no horizon, no land. What would life look like there, if it exists at all? We genuinely don't know, but the question alone is worth asking. So we come back to HD 137010b. One transit, 10 hours. A shadow crossing a distant star, and from that shadow, an entire world comes into focus. Imperfect, uncertain, and utterly fascinating, it sits at the edge of what we call habitable. It mirrors our own planet in ways that feel almost deliberate, and it remains, for now, one of the most compelling unanswered questions in modern astronomy. Because here's the thing, every great discovery in the history of space exploration began exactly like this, with incomplete data, with more questions than answers, with a faint signal that someone decided was worth chasing. Galileo had a crude lens, we have the James Webb Space Telescope, and the universe keeps offering us these tiny, flickering invitations to look deeper, think harder, and wonder more boldly. HD 137010b might be a frozen tomb. Or it might be the most important world we've ever pointed a telescope at. We don't know yet, but we will. That's it for today. If this kind of exploration is what gets you fired up, hit that like button and subscribe so you never miss a new discovery. Drop a comment below. I want to know, do you think HD 137010b is frozen solid, or could there be something hidden beneath that ice? See you in the next one.